So now instead of giving us numbers as our roots, it gives us a graph. So this problem is actually going to be easier than the previous ones because we don't have to sketch a graph anymore. We're given a graph. So the only information we need from this graph are the zeros. So I see that there's a 0 at 0. And then there's a double 0 at 3. So I'm going to write out x equals 3 twice. So it's really important that you understand that if the graph crosses through the x-axis, that 0 happens once. But if the graph comes down and bounces off of the x-axis, so it just touches it in one spot, that is a double 0, and that 0 counts twice. If you don't know that, you're going to get the wrong equation. All right, so I have my 3 zeros. The next thing I need to do is move them or rearrange them. Now the purple one, I don't need to do anything with that. It's already good because it equals 0. The teal one, I'm going to have to switch the sign, so I'm going to make it x minus 3. And then the pink one, the same thing. And then I'm going to set it equal to 0. So now this one is not so bad because I'm only going to have to FOIL once, and then I'll have to distribute that x. So it won't be quite as much work. So I'm going to start with these two binomials, and I'm going to FOIL those. X times x would give me x squared. X times negative 3 is negative 3x. Negative 3 times x is also negative 3x. And then negative 3 times negative 3 gives me positive 9. Now the middle terms do not cancel out because they have the same sign. So I'm actually going to be adding them, and I'll get negative 6x. So this turns into x squared minus 6x plus 9. And then I still have that purple x that we had at the very beginning. So now the only thing left to do is distribute that purple x. So it's going to get distributed to all three of these terms. And my final answer here is going to be x cubed minus 6x squared plus 9x equals 0. Now what I like to do, because you're given a graph, is to take this equation and put it into your calculator and kind of double check that your answer is right. So if I put this in my calculator and my graph looks totally different, I'm going to know that it's wrong. One thing you can do if you don't have a graphing calculator is you can look at your y-intercept. If you look at my purple equation here that the box is around, there's no constant number. So what that means is there's like an invisible plus 0 here. So that means that my y-intercept is at 0. So if you look here, the graph crosses the y-axis at 0. So that checks out. And then I'm going to just really quickly go to my calculator, and I'm going to type in the equation we just came up with. So that was x cubed minus 6x squared plus 9x. And when I press graph, it should look just like the graph that you see on your paper. So the scaling might be slightly different, but you can kind of make sure that all the arrows are pointing in the same direction and that it crosses at the right spots.